For this question, we want to find the domain of the function p of t equals square root of t minus 6 over 2t minus 16. Now, this is an interesting function because it can fit, parts of it fit into the different types of functions that we've been studying. But you can see that we have a square root in the numerator, but we also have a variable in the denominator. So it's a combination of a radical function, or sometimes we call it a root function, and a rational function. So we need to consider both of these ideas when we're finding the domain. So what we know about rational functions is that division by 0 is undefined. So because we have this variable in the denominator, we need to figure out any value that causes the denominator to be 0 and exclude that value from the domain. So our denominator is 2t minus 16. We're going to set that equal to 0. I'll solve this equation by adding 16 to both sides. That's 2t equals 16. Divide by 2, and t equals 8. So we have to exclude the value of 8 from the domain. But we also have a square root. And with a square root, or a root function, if it has an even index, like this one does, it's an even index because it's a square root. No index was listed here, so we assume that index is a 2. So when we have an even index, we want what's underneath our radical to be positive or 0. Because if we take the square root of a negative or the even root of a negative, that's going to give us a complex number. We only want to consider the real numbers, so we want the expression underneath our radical to be either positive or 0. So the expression underneath the radical, whatever is underneath the radical, we want that to be greater than or equal to 0. So our expression is 2t minus 6. We make that greater than or equal to 0, and we're going to solve for t. So we're going to add 6 to both sides, and we get t is greater than or equal to 6. Now let's combine these two pieces of information together. We need our variable t to be greater than or equal to 6, and we also need to exclude the value of 8. We can visualize this on the number line. So we're going to mark 6 on the number line, mark 8 on the number line, and we want to include all of the values that are greater than or equal to 6, but we do need to exclude that value of 8 because it will make the denominator 0. So this gives us a picture of what our domain is, and now we can write it in our interval notation. So we're going to start with 6. We're going to put a bracket on the 6. Bracket means that 6 is included in the domain. We want to go from 6 to 8. However, 8 is not a part of the domain, so we're going to use a parenthesis next to the 8 to indicate that it's not part of the domain. And then we have another group of numbers, another interval of numbers, starting with 8 and then going to infinity. And I've used parentheses on the 8 again to indicate that 8 is not part of the domain, and infinity is not a number, so infinity is the idea of it going on forever, so we're going to use parentheses on infinity as well. So here we have our domain in interval notation. Another way to write this domain would be in set builder notation. Let's see that. You would say that x is our domain, all x's, such that x is greater than or equal to 6, and x is not equal to 8.
Thank you for checking out my videos. Have a great day.